Okay, so now let's finish up number 60. This is going from 0 to 2 pi. So like that, with the parentheses around the 2 pi. And the problem is 2 cosine squared theta plus cosine theta minus 1 equals 0. So remember in the notes what we talked about on this is you could use your u substitution and factor. So the term that's in the middle is your u. So we're going to put u equal cosine theta and then change this to look like 2u squared plus u minus 1 equals 0. So basically you set your u to be the middle term and then figure out what it would look like. Some of these are, well, most of them are going to be factorable, but then some you may have to use the quadratic formula. So what this is going to look like is 2u there and u here. And if you've got a 1, then we need a 1 here and a 1 here. It's negative, so one of them's got to be negative and the other's got to be positive. And remember, the way we work it out is it's positive 2u squared, so that means right there and there, 2u times u is 2u squared. And then for the middle term, we're going to do 2u minus u to get u, so that means the minus has got to be there, and then the plus has to be there. So you're basically doing some factoring, and then set each one equal to 0. So you have 2u minus 1 equals 0, and u plus 1 equals 0. And then solve for u. So you move the 1 to the right, and then divide by 2, so you get a half. And this one you move your 1 to there, so you get negative 1. At that point, what you're going to want to do is change your u back to cosine. So we put cosine theta equal 1/2 and cosine theta equal negative 1. So then use your unit circle to work this out. Cosine theta is 1/2 when x is 1/2. And so this is when it's 1/2 square root of 3 over 2. And 1/2 with negative square root of 3 over 2. So you're going to have two answers for cosine 1/2. We look at our unit circle, and that happens at pi thirds and 5 pi thirds. And then for cosine equal to negative 1, remember that's when x is negative 1. And so that's over here at negative 1, 0, which is pi. And so your answers are pi thirds, pi, and 5 pi thirds. Pi thirds, pi, and 5 pi thirds. One other quick calculator note is when you have cosine squared theta, what you're going to have to do in the calculator is have some extra parentheses like that. Cosine squared theta needs to be cosine x and then close an extra parentheses and then do squared, so that it would look like this if you were trying to figure these out through the calculator. Go to a graph, then we do 2 trig cosine x. So you can't just put your squared right there because that just say x squared. We've got to have a parentheses Okay, so again, you can't just put your squared right there. You have to have parentheses around it. So there's your 2 cosine squared. Again, on paper we put the 2 in the middle, but on the calculator we don't. And then plus cosine x. And then we have minus 1. Okay, so there's your expression, 2 cosine squared theta plus cosine x minus 1. The right side is just going to be 0. Notice it's a little weird on how wavy it is. They're not all the same height because you've got a cosine squared. And what we would want is from 0 to 2 pi. So go to your settings, 0, 2 pi. And so anywhere there was an x-intercept, like 1, 2, 3 answers there, and those are going to match up with these 3 answers. So again, if you wanted to, you could go to Analyze, then Intersection, from here to here. That's your 1.047. And pi divided by 3 is 1.047. Okay, so again, you can check it that way. Then I'm going to go back to the current document and then get my next one. Menu, Analyze, Intersect between here and here. And let's move it. Okay, well there's 3.14159, which is pi, and then the other one would match also. Menu, Analyze, Intersect from here to here. 5.235. And so when I go 5 pi divide by 3, that gives me 5.235. The hard part is if you just start with a decimal and then you don't know if you're dividing by 3 or 4 or 6 or what. So that's why I'd work it out the regular way. But again, just as a side note on the calculator, if you have cosine squared, you need a parentheses in front of cosine and after the argument or parameter, and then you put your squared. So there's number 60. So we did our u substitution. By the way, if you didn't like u substitution, if you wanted to do shortcuts, you could have thought 2 cosine theta minus 1 times cosine theta plus 1. That's if you didn't want to do u substitution. It would look weird, but it's a shortcut. So if didn't use u substitution. Any questions? Okay. Next we have 64. And on this one we have cosine squared theta minus sine squared theta plus sine theta equals 0. So when I look at this, I see 2 sine functions and 1 cosine function. So I want to think about changing all to cosine. All to sine. Think about changing all to sine. So remember your Pythagorean identity that we're going to use is sine squared theta plus cosine squared theta equal 1. So if we solve for cosine squared theta, it'd be 1 minus sine squared theta. And so we're going to plug this in for cosine squared. So our cosine squared becomes 1 minus sine squared. And then we keep the rest the same. So minus sine squared theta plus sine theta equals 0. And then combine your like terms. So if you've got a negative sine squared and another negative sine squared, that's negative 2 sine squared. And then your sine theta is next. And then your number term or constant term is next. What we want to do next is multiply by negative 1. So that you have a constant, a positive number there. So we're going to multiply all those by negative 1, and we're going to multiply the 0 by negative 1. So that basically changes the sign of everything, because by doing this, it's going to be easier to factor. So this is where you say u equal the sine theta, because that was the middle, basically. And so you could say this is 2u squared minus u minus 1 equal to 0. If you didn't want to do that, it would just look like this: 2 sine squared theta minus sine theta minus 1 equals 0, and then just factor it. So here would be 2u and u. On this side it would be 2 sine and sine. So you can choose either of these. You don't have to write both. If you're going to do u substitution, use this side. If you're not, then do this side. Okay, so our next part is, we know we have to have a negative 1, so let's put 1 and 1 here. One's going to be positive, the other's going to be negative. And your middle term is negative, so that means we're going to have a negative 2u plus u. So again, over here, you're going to have a negative 2 sine plus sine. And again, set each of those equal to 0. 2u plus 1 equals 0, so u is negative 1/2, and u equal 1. And then you change your u to be sine theta. So sine theta is negative 1/2, and sine theta equal 1. And again, you get the same thing over here. If you solve for sine theta, 2 sine theta plus 1 equals 0. So sine theta would be move the negative 1 over and divide by 2. So the exact same thing we got here. And then this one, you would have said sine theta minus 1 equals 0. So sine theta is 1. So this is where they synchronize again, so to speak. So again, if you want to use u substitution, you can. Or if it doesn't bother you to factor with trig, you can do it that way. Either way. So now that you're at this step, you still don't know if there's going to be 2 answers, 3, or 4. So you've got to use your unit circle. Sine theta is negative 1/2 downstairs, so to speak. So where it's positive square root of 3 over 2, negative 1/2. And where it's negative square root of 3 over 2, negative 1/2. So this one is 7 pi 6. And and this one is 11 pi 6. So those are two of our answers. The other is when sine is 1, which is again the y value. So 0, 1 happens at pi halves. So that's right there. So then your answers would be pi halves, 7 pi 6, and 11 pi 6. Any questions? To this way? The top? Okay. I'm not sure how far. Okay, there. So again, this is probably the longest problem out of all of them. We first changed cosine squared to be 1 minus sine squared. Then we combined our negative sine squareds together to get -2. Then we multiplied everything by -1. And then decide whether you want to use u substitution or not. And then once you get your answers, then you got to use your unit circle. And so then it ended up being pi halves, 7 pi 6, and 11 pi 6. Okay. 68. So on this one we have cosine theta minus sine of negative theta equals 0. So what this one is talking about is when you have a negative in front of your theta, which is called an odd or even identity. So what it means is when you're doing sine of a negative angle, you're going this way, and now you're changing from one quadrant to the other, so you have sine of negative x equal negative sine x. So you'd actually have to change the sign. So that's your odd and even identity for sine. Bless you. Then for cosine, if you're going backwards x, then when you go up here, cosine is still positive for both of them. And so because of that, your identity is cosine of negative x equal positive cosine of x. So you don't put a negative sign like you do for sine. So that's how your formulas work. So what you would do then is you'd substitute. We change sine of negative theta to be negative sine theta. So what we have is cosine theta plus sine theta equals 0. Now, what you're going to want to do on this one is subtract cosine to both sides. So you have sine theta equal negative cosine theta. And then you want to divide by cosine to both. And change sine over cosine to be tangent. So you have tan theta And then this is where cosines cancel, so you just get -1. So when we're at this step, we had to manipulate our equation and change to just one trig function so that we know how to work it. Change to one trig function. And then tan is -1, where both are identical except for one of them is negative. So that happens there and there, which is at 3 pi fourths and at 7 pi fourths. So again, that's where it's negative square root of 2 over 2 with positive, and where it's positive with a negative. So our answers are 3 pi fourths and 7 pi fourths. So again, how this one was different than others is we had to change to one trig function because we were left with cosine plus sine equals 0. So we subtracted cosine, divided, changed it to tangent, and then figured it out on the unit circle. Any questions? Okay. 72. This one is sine squared theta equal 2 cosine 2 cosine theta plus 2. So on this one, we're going to keep our cosine the same, so we're going to change the sine squared to 1 minus cosine squared theta. Again, it's because of the Pythagorean identity. So if we're solving for sine squared, we move this to this side, and so that's why it's 1 minus. Okay, at this point, I would move my terms over. Let me just move the cosine squared over separate. So we have cosine squared theta plus 2 cosine theta plus 2. And then I want to move my 1 over. So I subtract 1 from both sides. And that's where you can use your u substitution if you want, where u equal cosine theta, or just factor it, where it's cosine theta, and 1 and 1, and it's pluses. And so again, we set that equal to 0, and so we have cosine theta equal -1 for both of them, and that only happens at pi, because that's at -1, 0. So even though there were two equations, they were identical, and cosine is only -1 at one spot, and so pi is your only answer. Any questions? So again, if you wanted to, you could have used u substitution and said u plus 1 times u plus 1 and then substituted back. But it's basically the same. There are times where u substitution is pretty useful, but this one it's pretty simple. So I just put cosine theta plus 1 for both. And again, like I was saying earlier, if you just wanted to graph this one, as long as you know what you're doing on graphing, then that's fine. We would go parentheses, sine x, go outside of the x and outside of the parentheses, say sine squared, and then that's that graph, and there's your 2 cosine x plus 2. So now we have to find where they intersect. On the positive side, menu, analyze, intersection between here and here, and that's where you get your 3.14159, which is pi. So you can use your calculator to check it if you need to. So that's your pi. Any questions? Okay. 76. You have 4 times 1 plus sine theta equal cosine squared theta. So again, you're basically doing algebra with trig. You want to distribute, so you do 4 times both of these. You get 4 plus 4 sine theta equal, and since we have sine here, we want to change cosine squared to be in terms of sine, so that'd be 1 minus sine squared theta. Same reason as before with your Pythagorean identity. Then let's move it over to this side to make it positive. 4 plus 4 sine theta equal, no, I'm sorry, plus sine squared theta equal 1. And then start rearranging so your squared term is first and your middle term. Then we want to move the 1 over, so 4 minus 1 is 3, and set that equal to 0. So again, if you want to use substitution, you can, or if you just want to factor it. This one's not too bad to factor, because if your last number here is small, then you probably don't need to use substitution. It's just 3, so you're going to do 3 times 1, and it's a plus 4, so it's going to work out. Bless you. So sine theta plus 3, sine theta plus 1. So to check it, sine squared, and then you have sine plus 3 sine is 4 sine, and then 3 times 1 is 3. So that's how it factors pretty cleanly. Then set each of those terms equal to 0, because when you're multiplying, that's what you do. So we have sine theta plus 3 equals 0, and sine theta plus 1 equals 0. And then just solve. So the sine theta equal negative 3 doesn't exist, because the graph would look like a regular sine graph from negative 1 to 1. The negative 3 would be down here, and so it doesn't cross, and so there's no solution for that part. But this other part, sine is negative 1 where y is negative 1, and that happens at 3 pi halves. And so that means your only answer is 3 pi halves. So until you work it out, you don't know if you're going to have 1, 2, 3, or 4 solutions. But in this case, there was only 1. Remember, like we said yesterday, if it said cosine theta equals 0, then there'd be two solutions right there and there. So it just depends on whatever trig function you have. And if it said sine theta equals 0, then it'd be pi and 0. So again, it just depends on the question. Okay. Next we have number 80. And on this one, we have secant theta equal secant theta equal tan theta plus cotan theta. So this one doesn't have any of the sines or cosines, and so that's what we want to convert them to. Convert to cosine or sine to make it easier. So secant is the same as 1 over cosine. Tangent is the same as sine over cosine. And cotangent is cosine over sine. So now we've converted them from your reciprocal identities. Secant is 1 over cosine. Remember the c and the s go together. Tangent is sine over cosine. That's the same as y over x. And cotangent is flipped. So what we want to do next is get a common denominator of cosine theta times sine theta. So we're going to leave our left side alone, but on this side we need cosine times sine. So what we need to do is multiply by sine over sine to get it. So then we'd have sine times sine is sine squared. And on this one we do cosine to both, and so we get cosine squared. So we have sine squared theta plus cosine squared theta. Now at this point, use your Pythagorean identity where that entire thing that I circled is equal to 1. So we're just doing a substitution. We have 1 cosine theta equal 1 over cosine theta sine theta. And the only time that would make sense is if sine theta equal 1. It's only true when sine theta equal 1. Because if it were equal to 1, then I cover it up and they match. So you have 1 over cosine for both. So that's only true when sine is equal to 1. And so that just happens up here at pi halves when it's 0, 1. So pi halves is your only answer. So basically we were getting a common denominator, which meant since this one had cosine down here, we need to multiply by sine over sine, and that's how I made it sine squared. And on this one it had sine here, so I needed to multiply by cosine over cosine, so that's why it was cosine squared. And sine squared plus cosine squared equal 1 is your Pythagorean identity. So that's how that one works out. Any questions? So again, this is using algebra to work trig questions. Okay, then our last ones are easy. They're just ones that you round. So 84, you have 19x plus 8 cosine x equal 2. Say the left side's function 1, the right side's function 2. So we go 19x plus 8 cosine x, and then we put 2. Okay, so there it is, and you just do your intersection. Menu, analyze, intersect between here and here. You have negative 0.297 comma 2, because that's what would make sense, because your y value is 2. That's your ordered pair, and so then your answer is negative 0.30, because they want you to round to 2 places. That's the 100th. Okay, and then our last one, number 88, you've got x squared plus 3 sine x equals 0. So again, put function 1 on the left, function 2 on the right. X squared plus 3 sine x, and then you put 0. So you basically want to know where these x-intercepts are. And so you go menu, analyze. You can either do intersect or 0, since it is 0. Between here and here, that's negative 1.72 2 comma 0. And then the other one, it's going to be the origin, I think. Analyze, intersect from here to here. That's 0, 0. And so that means your answers are negative 1.72 comma 0. Because again, we want to round to the 100th. Okay, so that's the end of the lesson. We're going to skip the one on the word problem so that you can have more time to work on your Math Excel.